Hi, my name is Anthony Osorio, and we would like to talk about the Nightcast, which involves an awning system that implements LED strips and LDR sensors controlled by Arduino. This awning sits overhead a solar panel, which would allow for energy generation for cloudy days or nighttime conditions. To continue on, he then will lay out and explain in further detail the concept development options that we came up with for the Nightcast system.
In Senior Design 1, we had to think about options that we wanted to have for our concept of the Nightcast. On this diagram, we laid out 3 key components that would make up the Nightcast, which is the awning component, the LEDs, and the solar panel. From our starting diagram, we laid out 3 options that we can choose on how we want to fully implement the Nightcast. And then from there, we created tables on how we feel about each option when it comes to power efficiency, easy installation, low cost, and reliability. From those calculations done on each option, we decided to choose option 3, which had the highest score out of the other 2 options. This would be how the Nightcast would turn out from chosen option 3. And now Alejandro will go on to explain the end product of the Nightcast.
This block diagram is what makes up the Nightcast, which starts with the 18 mega processor with GPIO pin headers that are used to establish important connections, and would receive power from the 12-volt lithium-ion rechargeable battery that is connected to a 5-volt DC power connector. Then, at the bottom section of the diagram is where we would list the sensory array with the pin headers, which is our photoresistor that is used to activate the awning of the Nightcast. From there, on the top of the diagram, we would have a connection established for the 36 kilogram servo motors, which is needed to create the moving mechanism for the awning component. Also, it was our intention to integrate the servo motors onto the awning system, but unfortunately, the weight of the awning shell was too much torque for the servo motors. Each of these components would then be a part of an Arduino program for commands that would have the RGB LED strips turn on or off depending on how the light is reflected onto the photoresistor, which activates the code. Continuing forward, Anthony will show a demonstration of the Nightcast.
This code uses a photoresistor, which is a light sensor, to detect the presence or absence of light. It initializes the LED strip controller and sets up the pin assignments. In the setup function, the LED strip is turned on and off once to ensure it starts in a known state, and the initial light intensity is read from the photoresistor. Depending on the initial light intensity, the LED strip is turned on or off accordingly. In the loop function, the light intensity is continuously monitored. If there is no light or the photoresistor is covered, the LED strip is turned on if it was previously off, or if it was turned off due to the light shining condition. If there is light, the LED strip is turned off temporarily if it was not already off. The code waits for 100 milliseconds to allow the LED strips to adjust to the new state before reading the light intensity again. The program keeps looping, repeatedly adjusting the LED strips based on the light conditions detected by the photoresistor. The goal is to turn the LEDs on in the absence of light and turn them off in the presence of light.